Let's chat a little bit about vectors. So a vector is a directed line segment. So it has both a direction and a magnitude. So direction, you know which way you're going, and you know how far you're going. So examples of that might be something like velocity, a force, something like that, where you know which direction the force is pushing and how far the force is going. The other thing that's sort of central to vectors are scalars, and a scalar is a quantity, or you could say just a magnitude. So if something was 18 pounds, you would just know that quantity or heat or something like that. Now, if you have 2 points, let's say A and B in the plane, and you know that a vector travels from A to B, you'd have to have an arrow somehow, and often we would denote that A to B. Another way to denote that would be AB with an arrow that looks like that. Now, a vector doesn't inherently have a starting point. Okay, so vectors are independent of a starting point. That means they can start at the origin or they can start anywhere else. If you think about a river that is flowing in some direction, it has a velocity. It's each particle of water is going the same direction, but you could sort of look at that in different places. And you'd have to imagine a river where everything was sort of flowing the same direction at the same speed. Now there are a couple of other notations just so we can get those out in the open. You might have just a single letter B, or you might have a capital B, or you might have a bold letter, so that's a little harder to draw, but something like A. Sometimes you have lowercase Greek letters, something like that. Okay, so we have all those notations, but remember it's independent of its starting point. So here's an example. Let's imagine that you had these 2 vectors here. Well, I might as well start them at the origin. Notice that this one starts at the origin and ends at the point 3, 1, but you know, it might just as well start at the point 4, 0 and end at the point 7, 1. It's got the direction and it's got a magnitude. If we called this vector A and we called this vector B, where would the vector A plus B be? If these were 2 forces, both acting at the same time, let's imagine that B was the force of the river, and C and A was the force of maybe somebody paddling some direction. Well, where would be the net force? Well, you could move the force of the river to start here. Notice that it goes 2 right and 4 up. That means it should end right there. So that would be the net A plus B vector. Notice you could also move A to start at the end of B. So that's sort of the aggregate. You could do that using this sort of notation too. This notation assumes starting at the origin, where would you end up? Well, notice vector A would end at the point 3, 1, vector B would end at the point 2, 4. You could look at the picture and say starting at the origin you'd end at the point 5 and then 5, or you could say, well, I'm just adding the x directions and I'm adding the y directions and all is well. You could also say, let's imagine that this was a velocity and you were going in the direction of A 2 units of time. And so what we would have is then we would have something like 6, 2, and you could see that that would be like going A, and then if you wanted to draw that line would be 2A. Okay? Well, you can sort of see what I'm going to talk about over here. Let's imagine that we have A, but somehow we want to take away B. Okay, so now since positive B starts here and ends there, you can think of negative B as ending there and starting there. So we're going to take B and we're going to move it this direction. So there's B. Okay, and so the net A minus B vector is the one that starts at the origin and ends at the point 1, negative 3. And you can sort of see how that calculation works here, right? Let's see, so 3 minus 2 is 1, 1 minus 4 is negative 3. Let's see if we can't think about the other way to do this. Well, if you wanted to start with negative B, I guess that would end you right here, right? There's B. If you wanted to go negative B and then positive A, that would get you to the same place. Okay, and last but not least, you could take a vector and you could scale it in the positive direction. I should mention these are called scalars, those are quantities. Or you could send it in the negative direction, and then what that would mean is if a full 1 in the positive direction is 3, in the negative direction 1/2 would be 3/2, and this would be negative 1/2. You could really do this game independent of a coordinate chart. So for instance, if somebody gave you a vector C and they said, hey, vector C has this magnitude in this direction, what is 1/2 C? It doesn't have to start at the same point, but it does have to have the same direction. And we'll pretend like I got that line exactly half the magnitude of the original C.